Subscribe to my channel and press the bell icon for latest notification about my videos.
A warm welcome to you all. Now today we are going to discuss a new topic that of class 11 physics, that is rotational motion. So let's rotate with rotational motion. Now, the very first, we have to go to the very basic concepts of rotational motion, for which we have to state that the some terms as like omega, alpha, L, I, etc. Now, for the very basic concepts of rotational motion, you have to go, if you consider a circular particle like this. Okay, a circular disk, a system of particle, a circular disk having n number of particles is if you consider this to be a rigid body, then, and this, suppose this line to be A and B, this to be the axis passing through the center of this disk. Then if you rotate that particular disk in this direction, then what we will see? We will see that this particle, or any particle, if you consider this particle, suppose this particle to be small a, then after a certain time this particle A will be over here, this particle will be over here, this particle will reach over here, so it will cover an angular distance. So if we make this, call this angle as theta, and this linear distance which this particle covered as S, and the radius of this particular disk to be r, then we will get a relation between linear and angular displacement. This S is termed as the linear displacement and this theta is termed as the angular displacement. So we know that this theta, as these both are time dependent quantities, this S is directly proportional to theta. Look at this, and if you remove this proportionality sign, we will get a constant, and this constant is nothing other than r. As because if this r remain constant in this entire system of rotation, then only we will get this result in this relation between these two, that is S is equal to theta r, or S is equal to r into theta. Now this theta is an axial vector. Okay, means to get the direction of this vector, you will use the right hand thumb rule. Means that if this particle is covering a distance in this anti-clockwise direction, then we will encroach our right hand fingers into the direction of this rotation. So if we encroach this, we will get that the direction of our thumb is towards the upward direction. So this upward direction indicates that the vector, or the direction of this vector, is over this axis. If we term this as theta hat, then we will get that theta is equal to theta into theta hat. So now I think you all are pretty clear about the quantity of relation between linear and angular displacement. Now we are proceeding towards the next topic, that is of angular velocity. Now for angular velocity, we will be just comparing this angular terms with the linear terms, okay, which we are used to. So let's see that we know that if this x gives the distance covered by a particle, then we know that d dt of this x gives us velocity. Okay, linear velocity, v linear, and this ddt of this v gives us acceleration. This is also a linear quantity. So if we compare this with the angular terms, then what will we get? We will simply be getting that if we transverse, if we substitute this x by theta, then you will simply get that d theta by dt. Okay, or if you write over here that it is ddt of theta is equals to one new term will come. This linear velocity will be replaced by angular velocity. So we represent this angular velocity by the Greek letter omega. Okay, omega. Now, similarly, if we substitute the value of v or ddt of v by ddt of omega, then what will we get? We'll be getting that ddt of omega is equal to angular acceleration, that is alpha. So I think it must be clear to you all that the substitution of the very easy steps of the circular motion kinetics, that is the ddt of theta is omega and ddt of omega is alpha. It is angular acceleration, this is angular velocity. Now we proceed towards our next topic.